We're doing the first derivative test today, which tells us about our relative extrema. So we're going to be able to calculate our extrema without a calculator. Whoop. I told you we are going to be able to do that last year and also this year, I think. All right, so the other thing that we can see when we calculate the extrema is where the function is increasing and what intervals the function is decreasing. So we know that if the function is continuous on a closed interval and differentiable on that open interval, then f prime of x, so the derivative of x, if it's greater than 0, then all x values are going to be increasing on that interval. Then if we have f prime of x is less than 0, so if the slopes are less than 0 on the original function, then we know that the function is decreasing. And if f prime, which describes the slopes of the original function, then we know that the slopes are increasing, or are constant. All right, so let's go ahead and take a look at this little graph. This is the graph of f of x. And basically what we're saying is we're going to find the derivative when f prime of x is equal to 0, because that's when the slopes are 0 and we have a relative min or a relative max. You can see that when our tangent line, the slope of our tangent line is positive, our function is increasing. It's getting larger. The values are getting larger. And when the slope of our tangent line is decreasing or is negative, then we know that the function itself is decreasing in value. So what we're going to do first is take the first derivative, find the critical numbers, set up a number line. We're going to test the numbers in between our critical numbers, which are our relative maxes and our relative mins. And then we're going to just write out our answer. All right, so first up, if we're going to find the relative min, we're going to find the intervals of increasing and decreasing for the function f of x is equal to x cubed minus 3 halves x squared. So first off, we got to find f prime of x, which is 3x squared minus 3x. All right, next up, critical numbers. There's nothing that makes this function undefined, so it's none. And then for the zeros, I have 0 is equal to 3x squared minus 3x. I'm going to factor 3x times x minus 1. So I get x can equal 1 or x can equal 0. So these are my critical numbers. I need to put those on my number line. So second, I'm going to put those on my number line. I'm going to make my number line a little bit lower. Okay. And I always draw my number line as if the graph is going from negative infinity to infinity on the x, and I have critical numbers at 0 and 1. We're describing the outputs of f prime of x, so I always write that down because we can write a number line for f of x, f prime of x, f double prime of x. Okay. Third up is to test the values, the intervals between our critical numbers. So I need to test a number in between negative infinity and 0. So I will choose, let's see, negative 1. How about negative 10? All right, I'm just going to plug it in I'm going to use this factored form of my equation because I know that 3 times a negative 10 times a negative 10 minus 1 is going to give me, well, that gives me a negative, and then the second set of parentheses is also going to give me a negative, which is in the end is going to give me a positive. Okay. Next up, I'm going to choose 1/2. So 3 times 1/2 times 1/2 minus 1. That is a positive. 1/2 minus 1 is a negative, giving me a negative. A positive times a negative gives me a negative. Last up, I'll choose 10, positive 10. So 3 times positive 10 times 10 minus 1. I can see I get a positive and a positive, which is going to result in a positive. So from there, the output, I know that anywhere between negative infinity and 0, the derivative is going to be a positive value, which means that that f of x is increasing in value between negative infinity and 0. And then the slopes of f of x, f prime of x is, f prime of x is going to give me a negative value, which means that the slope of the original is negative. So we're going to be decreasing and then increasing. So if I go back to my original function here, remember we said that from negative infinity to 0, we were increasing, and then from 0 to 1, to x equals 1, we are decreasing, and then from 1 to infinity, we're increasing. So taking the derivative is just, and using this first derivative test is just giving us a picture of a mathematical picture of what is happening on our intervals of increasing and decreasing in our function. So the last thing to do is to write out our answer. So we are increasing from negative infinity to 0 or from 1 to infinity, and we are decreasing from 0 to 1. All right. So what we're saying is that another thing that we can use the first derivative for, besides finding our intervals of increasing and decreasing, are to find the relative minimums and maximums. So if we let C be a critical number on a function that is continuous on an open interval, and it contains the point C. If f is differentiable on the interval, except possibly at C, then f of C can be classified as the following. So f prime of x changes, so there's two things. It changes from negative to positive at the C value. So from decreasing to increasing on f of x. Then f of x has a relative min at C comma f of x. So if f of x changes from positive to negative, we have a relative max. And if f prime of x is positive on both sides of C or negative on both sides of C, then we don't have a min or a max at our critical number. Okay, so I have a little picture for you what that's going to look like. And I will plot in what an example of a number line would look like here. So if this is f of x, f prime of x would look like at x equals 2, the slope, the function is decreasing then increasing. So a negative to a positive derivative. So we have a relative min at this point. Okay, so we're decreasing to increasing, which means we have a relative min. If we are looking at the second graph at x equals 2, we are increasing on f of x, and which means that our derivative is positive. And then we are decreasing after 2, which means our derivative is negative. The output of our derivative is negative. So then we have a relative max. So increasing to decreasing. All right. If f prime of x at x equals 2 is increasing and then increasing values, then we have no relative min or max. And the same is true also for the second graph. We are decreasing till 2 and then decreasing again. So decreasing, which means we have no relative min and max. We really have to change from a positive to a negative slope or a negative to a positive slope in order to have a relative min or max. It's got to create that hill or the valley. All right, we're going to use the first derivative test to find the relative extrema And then also state the intervals of increasing or decreasing for the function f of x. And so let's do this. Number one, we're going to find f prime of x. All right, of 1/2 x would be 1/2 minus negative sign would give me a negative cosine of x derivative. All right, critical numbers. Anything make our function f prime of x undefined? Nope, so nothing. Zeros, we set our function equal to 0, so 1/2 minus cosine x. So cosine, when does cosine x equal 1/2? And that is pi over 3, and then reflected. So x, when x is equal to pi over 3, and then 2 pi minus pi over 3 would give me 5 pi over 3. Double the bottom, subtract 1, remember. So now we set up our number line. And this is the number line of f prime of x. And we have to use our, actually this is on a closed interval, so from 0 to 2 pi. So instead of arrows, I'm going to put my endpoints. And then I have a point at pi over 3 and a critical number at 5 pi over 3. All right, time to test. So is f prime of, let's see, let's choose a value right here, like pi over 6 or 30 degrees would give me 1/2 minus cosine pi over 6, which is 1/2 minus root 3 over 2. Root 3 over 2 is larger, so we're going to get a negative. Okay, just put them in parentheses. F prime of, let's go right here. And we're going to put a pi, like pi is in between these values. So 1/2 minus cosine of pi. And cosine of pi is -1. So I get, right? Having a moment. Yes, -1. So this is a positive value, positive. Cool. All right, f prime of 11 pi over 6, because 11 pi over 6 is in between 5 pi over 3 and 2 pi. I get 1/2 minus the cosine of 11 pi over 6, which is 1/2 minus root 3 over 2. We've seen that before, so that is a negative. Okay, so what is happening with this function? I ran out of room. Okay, so for f of x, we're going to be decreasing between 0 and pi over 3, increasing from pi over 3 to 5 pi over 3, and decreasing from 5 pi over 3 to 2 pi. So we can write our intervals. We're decreasing from 0 to pi over 3, or we're decreasing from 5 pi over 3 to 2 pi, and then we're increasing from pi over 3 to 5 pi over 3. All right, and our relative min is at, okay, a relative minimum, we always write it as a point, so it's going to be at pi over 3, and then we got to find our coordinating y value. And then I'll go ahead and write our relative max too. Our relative max, because we're decreasing and then increasing on our original function at pi over 3, we'll have our relative min, and then we increase to decrease at 5 pi over 3. So the x value of our relative max will be 5 pi over 3. Now we have to find the coordinating y value. So f of pi over 3 is equal to 1/2 minus, 1/2 x minus the sine of pi over 3. And the sine of pi over 3 is root 3 over 2. Yep. So I have 1/2 x minus, 1/2 times pi over 3 minus root 3 over 2 is equal to pi over 6 minus root 3 over 2. And I am going to leave it like that. Okay, so I have pi over 6 minus root 3 over 2. That's our relative min. Our relative max is at 5 pi over 3. So I do 1/2 times 5 pi over 3 minus the sine of 5 pi over 3. And I just remember that the sine of 5 pi over 3 is negative root 3 over 2. So I get 5 pi over 6 minus root minus root 3 over 2 gives me 5 pi over 6 plus root 3 over 2. So 5 pi over 6 plus root 3 over 2. And these are our answers. All right, one more. You guys do this one, and then we'll check in. You should pause the video and do it. All right, same. We're going to find f prime of x. And I can see right now this would be a lot easier. You can use the quotient rule. I'm going to divide x squared into x to the fourth, which gives me x squared, and then plus x to the negative 2. Now I can take the derivative using the power rule, which gives me 2x minus 2x to the negative 3, which I can rewrite as 2x minus 2 over x cubed. And I notice that I have an undefined value at x equals 0 because of the denominator here. So now it's time to grab my zeros. So 0 is equal to 2x minus 2 over x cubed. I'll add this to the other side. So 2 over x cubed is equal to 2x. I think I'm just going to cross multiply. 2x to the fourth is equal to 2. Divide x to the fourth is equal to 1. And I get x is equal to plus or minus 1. So I have three critical numbers at x equals 0, x equals 1, and x equals negative 1. We are not on a closed interval, so all I need to do is set up a number line for f prime of x that is infinite on both sides, and then have my negative 1, 0, and 1. If the critical number is undefined, I usually put in a vertical asymptote to remind myself that that is an undefined value and not a 0. Now, time to test. Always testing. So I'm going to do f of negative 2, f of negative 1/2, f of 1/2, and f of 2. And you guys are going to go ahead and start plugging in those values to get your positive and negatives. I substituted in our values in between our intervals. And for the first f of negative 2, I got a negative. Okay? And then for f of negative 1/2, I see that 2 divided by a fraction divided by a negative fraction is going to give me a much larger number. So negative 2 plus a larger number is going to give me a positive. The same thing is true for f of 1/2, but instead of a positive number in the back, we're going to end up with a large negative number. So we're going to get a negative when I add 1 minus a large number. And then 2 over 8 basically is a fraction. So 4 minus just a small less than 1 value is going to give me a positive. Okay, so negative, positive, negative, positive. You also need to know how to get these values in your calculator. Okay. So what does this tell us about f of x? It tells me that the graph is decreasing, increasing. Then there's an asymptote, or something that is not differentiable. Then it decreases and increases. I have my answer as my function is increasing between negative 1 to 0 and 1 to infinity. it decreases from negative infinity to negative 1 or 0 to 1. And then I have a relative max at, let's see, max would be increasing to decreasing, and there's an asymptote there, okay? So I have none. How do I know there's an asymptote there? If I look back at my original function, remember my denominator is restricted because we're dividing by x squared, so I can't divide by 0. And we have a relative min at negative 1 comma something at the value between when I'm decreasing to increasing. So I have a relative min and a relative min, and at positive 1. And then I have to find my coordinating y values. So f of x is equal to x to the fourth plus 1 over x squared. I'm going to find f of negative 1, which is negative 1 to the fourth minus 1 over negative 1 squared. Looks like I get 1 minus 1, which is 0. Okay? And then f of 1 would be 1 to the fourth minus 1 over negative 1 squared. So 1 minus 1 is 0 over 1, which gives me 0. So I have relative minimums at negative 1 comma 0 and 1 comma 0. Remember, these y values are not always the same because the relative minimum could look like we could have two relative minimums at different heights, okay, but for different intervals. That is our first derivative test. It lets us find our relative minimums and maximums, and then also it tells us our intervals of increasing and decreasing. Cool.